All right. So challenge problems naman. So we tackled the basics. So ito naman, I will just give you examples of, how you can push your envelope, like even further, no? So para matest talaga yung kumbaga kung gaano ka deep yung understanding niyo ng mole concept. All right. So ito naman. So how many water molecules are there in 12.5 grams of ice? So ito naman, so from mass, diretso na tayo sa number of particles. So again, ice is solid water. So dapat kayo ay kumbaga receptive din kayo dun sa mga nuances na ganyan sa exams kasi mga trick yan minsan eh. Okay. This is how you would set it up. So based on this relationship, in order to convert a mass to the number of particles, in this case, it's number of water molecules, you have to go through two steps. So you have to divide by the molar mass to get to the amount in moles, and then convert the amount in moles in term, to the number of particles by multiplying with the Avogadro's number. So this is how you should set up the equation. So mass of water, you're given this. You have the molar mass of water, which is 18 grams per mole, and then the Avogadro's number is a constant. You should know its value. And then what we do is that after setting up this equation, you have to plug in your number. So ang binigay sa iyo is 12.5 grams of water, and then divide it by 18 grams, and then you multiply it by the Avogadro's number. And this is how you should approach your dimensional analysis. So 12.5 grams divided by 18 grams, so you can cancel out the gram unit. And then from this, yung mole kasi mapupunta sa numerator, no? So again, this is like division of fractions. So yung mole mapunta sa numerator, and then you have a mole sa denominator, magka-cancel out din yan. So ang natitira na lang sa inyo is yung unit na number of particles. So yung answer dito should be 4.2 times 10 to the 23rd power. All right, that's the number of water molecules present in 12.5 grams of ice. All right. Ito naman, volume of a substance to the number of particles. So, question is, how many moles are there in 36 ml of water under standard conditions? So, ang dami na, there's a lot of things to unpack here. So, 36 ml of water. So, you're given volume. How do you convert volume to mass? So, dito, kailangan kayong gumamit ng density, and that's the reason why nagbigay sila ng condition under standard conditions. And what do we know of, ano ba yung density ng water when it comes to under standard conditions? So ito mali pala to, hindi siya ambient, no? Standard condition. So usually ang water naman for educational purposes, like it's at 1 gram per mole. Though if we are going to be very technical about this, yung conditions kasi, so density is very sensitive to temperature. So sometimes kapag sobrang off yung temperature, kapag malayo sa standard or sa room condition, for example, usually nagde-deviate siya sa 1 by a few decimal places, so 0.99 something. So kapag na-specify nila yung temperature na outside of standard conditions, you have to check yung mga references, no, kasi minsan mas mababa yung density ng water. Pero for our intents and purposes, we're actually going to use 1 gram per mole. So how do you do that? So the first thing that you have to do is to convert the amount of, or the volume of water into its corresponding weight. So ito, we have 36 ml, we're given 36 ml. So what you just have to do is to multiply it by the density. So 36 times 1 gram per ml of water. Again, do your what they call this, dimensional analysis. So the answer that you'll get is 36 grams of water. So yun na yung mass nyo. And then pag nakuha nyo yung mass, you just have to plug it into the exact same series of equations. So you have to go through the same process. You have to divide the mass by the molar mass, which is 18 grams per mole, and then multiply multiply the quotient by the Avogadro's number. So in this case, what you will get would be 1.2 times 10 to the 24th power. So kumbaga mas marami siya. Bakit mas mataas sa Avogadro's number? That's because you have more than yung weight ng water mo is actually higher than the molar mass. So things to watch out as well. All right. So volume to number of particles, ay ito naman, ito medyo trick question ito. So how many hydrogen and oxygen atoms are there in 36 ml of water? So this time around naman, di ba yung kinocompute kasi natin kanina is number ng molecules ng water. So ano nga yung composition ng molecule of water? Ang molecule ng water is composed of 2 atoms of oxygen and 1 atom of 2 atoms of hydrogen and 1 atom of oxygen. So for problems like this, ang tanong kasi is number ng hydrogen and oxygen atoms, not number ng molecules ng water. This requires a very good understanding of chemical formula. So dapat pag nakita to ng mga estudyante, dapat mare-recognize nila na ay ang tinatanong ay hindi number ng molecules but ilan yung bilang ng hydrogen atoms at oxygen atoms dun sa 36 ml ng water. So kung hindi nila alam na ang water ay may formula na H2O at ang ibig sabihin nun ay ito yung composition, dito medyo mararatal na yung student kasi ay paano ko to sasagutin? Paano ko bibilangin yung hydrogen at oxygen atoms? So students in the audience, take note of this. 1 molecule of water is composed of 2 hydrogen atoms and 1 oxygen atom. So ito, magagamit natin to as we solve this problem. So yung unang step na kailangan nyong gawin dito is you were given 36 ml of water, which we have solved already kanina, di ba? Nakita nyo na ang sagot dito is sa 36 gram, you have 1.2 times 10 to the 24 molecules of water. So this answer is one of your givens, no? So what you'll do is that you'll use the relationship that we discussed earlier. So if we are calculating the number of hydrogen atoms present in 36 grams of water, so that would be 1.2 times 10 to the 24 molecules of water multiplied by this conversion factor. So 2 hydrogen atoms are present in 1 water molecule. And so what you do is you cancel out the unit. So this value multiplied by 2 would give you 2.4 times 10 to the 24. So that's the number of hydrogen atoms. So which makes sense kasi 1 molecule of water, 2 hydrogen atoms. So if you have 1.2 times 10 to the 24 times to the 24 molecules of water, doble nun yung number ng hydrogen atom. So when it comes naman to oxygen atoms, you also use the same conversion factor that I detailed earlier. So 1.2 times 10 to the 24, and then we know that there is 1 oxygen atom for every molecule of water. And then again, it's all a matter of dimensional analysis. Cancel out the units wherever applicable, and your answer should be this. So for every So there should also be 1.2 times 10 to the 24 oxygen atoms. So kung gaano kadami ang bilang ng molecules, ganoon karami ang bilang ng oxygen atoms. So yun, and so essentially this is how you kumbaga challenge yung student. So kapag natutunan nila yung pag-compute ng moles to number of particles or to mass, pwede nyo siya lang i-challenge by putting in yung complex chemical formula, or you could put in structures na from the chemical structure, magbibilang sila ano ba yung composition nito, ilan ba yung carbon, ilan ba yung hydrogen, for example. And then once na na-define nila yung composition, you can ask them to calculate yung number ng individual atoms. And number ng atoms of each element in the particular substance. All right.